8th grade. We're ready for the last section in Chapter 6. Today you'll be learning how to solve systems of linear inequalities. Now to solve these systems, you'll simply be graphing two or more inequalities on the same coordinate plane, and you learned how to graph those inequalities in Lesson 5. The solution to a system of inequalities is simply the overlapping shaded, double shaded region. And to determine if you have a solution of the system, you just need to make sure it makes both inequalities true. Let's graph some examples. In this first example, we have two inequalities. Y is less than or equal to 3, and y is greater than negative x plus 5. So we'll begin by making our x and y axis. We're going to graph these lines one at a time. Both of them are solved for y. Now remember, if you're comparing y to a number, that is going to be a horizontal line because you're going to be graphing the line where no matter what your x is, your y is equal to 3. I'm using a different size grid today, so we're just counting 1, 2, 3. Here's the line. Y is equal to 3. It's going to be a solid line because we have a bar underneath the inequality symbol. Y is less than or equal to 3, therefore I shade the region below the line, so I have a horizontal line, solid line because it has a bar, and I'm shading below. Now the second line that I'm graphing has a y-intercept at 5, so I begin my line at 5. 1, 2, 3, 4, 5. I have a slope of negative 1, so I'm going to go down 1 over 1 to get my second point. And I'm going to make a dashed or a dotted line because there is no bar underneath the greater than sign. I'm going to extend the line so that I can see my shaded region. For the second inequality, I'm shading the region greater than y, so I'll be shading above the line. Now the solution to this system of inequalities, is the double shaded region, which is this region right here. Any point in this area right here is a solution and will make both equations or inequalities true. So for example, I can pick this point right here, which is the point 1, 2, 3, 4, 1, 2, 3, 4, and up 2, so that's 4 comma 2, and 4 comma 2 will make each inequality true. So for the first inequality, I have 2 is less than or equal to 3, and that's a true statement. And if I put 4 comma 2 in the second inequality, I get 2 is greater than negative 4 plus 5. Negative 4 plus 5 is 1. 2 is greater than 1 is also a true statement. So I have my solution, again, is in the double shaded region. Let's try another example. This time I'm going to use the two inequalities. Negative 3x plus 2y is greater than or equal to 2. Now remember, I need to solve for y and put this in slope-intercept form. So I'll be adding 3x to each side, giving me 2y is greater than or equal to 3x plus 2. Then I'll divide each term by 2. 2 over 2 is 1, so that gives me y is greater than or equal to 3 halves x plus 1 because I divided this term by 2 and this term by 2. This is my first equation or inequality. My second inequality is y is less than 4x plus 3. I will graph them in different colors. So graphing the first line, I'm going to use the y-intercept 1. I'll graph this one in blue. Y-intercept is 1. The slope is positive 3/2. So I'm going to go up 3 over 2 to get my second point. This one is a solid line. It has a bar underneath. So there's my solid line. I'm graphing y greater than or equal to, so I'm shading above the line. Now I'm graphing the second line. The second line I will graph in red. So that's this one right here. And my line, the y-intercept from my line is 3. So I'll go up 1, 2, 3 to the y-axis. My slope is 4, so I'll go up 4 over 1. There's my second point. This line will be a dashed line because there is no bar underneath. Remember, you use a ruler so that your line is accurate. My inequality on this problem is y less than 4x, so I'll be shading below the line. You see the double shaded region? You see the region that is true for both statements? It's this one right here. So a solution for this system of inequalities would be, for example, this right here, which is the point 0, 2. And 0, 2 is true for the first inequality because, going down here, 2 is greater than or equal to 3/2 times 0 plus 1, or 2 is greater than or equal to 1. And for the second inequality, if I put my ordered pair in that second inequality, gives me 2 is less than 4 times 0 plus 3. 4 times 0 is 0. That becomes 2 is less than 3, which is also true. These are both true statements, so I have shaded the correct region. Let's try another example. In this example, I have the inequalities y is less than or equal to negative 2x minus 4, and y is greater than negative 2x plus 5. These are both solved for y, so I do not need to do that. I'll just graph both my lines. Top equation or inequality, my y-intercept is at negative 4. I'll graph that in red. 1, 2, 3, 4 below the origin. My slope is a negative 2x, so that's down 2 over 1, which gives me the second point. I have a solid line because there's a bar underneath. So I'm going to draw my line, nice big line, and I will shade below the line because it's less than or equal to. There's my first solution. For my second solution, oh, notice we have the same slope, so we're going to have a parallel line. I will graph this line in blue. For this particular inequality, my y-intercept is 5, which is right here. My slope is down 2 over 1, which is right here. I have a dashed line because there is no bar underneath. So here I go. And I'm going to shade above the line. Now remember, the solution to a system of inequalities is the double shaded region. There is no double shaded region for this particular system, so we say there are no solutions. That's what happens when you have a set of parallel lines that shade in opposite directions. Moving along for another example, we're going to graph the two inequalities y greater than 3x minus 2 and y is less than 3x plus 6. Now if you're paying attention, you'll notice that these will be parallel lines as well because they have the same slope. Let's see what the solution set for this set of lines is. Top line, my y-intercept is at negative 2. I'll graph this in red. My slope is 3, so I'm going to go up 3 over 1. It's a dashed line because there is no bar underneath. Sorry, my line is crooked, but you'll be using a ruler. And I'm shading above the line because y is greater than. So here is my shaded region. Now for the second line, which I'll graph in blue. Again, this time my y-intercept is 6. Right here. My slope is still 3, so I still go up 3 over 1. I will be drawing another dashed line. There is no bar underneath. Here's my somewhat parallel lines, which if I used a ruler would be exactly parallel. This time I'm graphing, yes, I'm graphing below the line because it's y less than. So I will shade underneath that line. You see the double shaded region? The double shaded region is the regions between the two lines. So it's this region right in here. Anything in this region right here will be a solution to my inequality. Finally, I have one more example to show you. I'm graphing the two lines. Y is greater than or equal to 4x plus 6, and y is greater than or equal to 4x minus 5. Yes, you'll see that we have one more example showing parallel lines. So we have a third case to show you. Remember, the first case was no solution. There was no double shaded area. The second case was shading between the two lines. Let's see what we have here. So the very first one, which I'll shade in red, has a y-intercept of 6. 1, 2, 3, 4, 5, 6. Slope 4. So up 4 over 1. I'm drawing a solid line because there is a bar underneath it. Oops. Hold on. And I'm shading above the line because it's greater than. So I'm shading in this direction. Second line, I will draw in blue. Y-intercept is at -5. Slope is again 4. So I'm going to go up 4 over 1. This one is also a solid line because there's a bar underneath it. This one is also shaded above the line because it's y greater than or equal to. So here we see our third example for parallel lines. And in this case, our solution set is everything above the first line that I graphed. So it's everything in the region y is greater than or equal to 4x plus 6. That's all for today. When you come in tomorrow, you'll be able to practice these problems.